We're going to cut to the chase. We don't have much time here today.
No, we need to get through this one. This one's going to be long, so bear with us.
Learning targets.
Let's do that. It's a necessary evil. When we're done with this, we will be identify the name of the different groups and families on the periodic table.
Ready? 1, 2, 3, team.
Quickly.
All right.
Let's go.
Take it away.
Sure. These are the alkali metals that we're starting with first. They all have one valence electron. Since they're metals, they have luster, conduct electricity, they're ductile, and malleable.
Can we define that ductile and malleable quick?
Quickly. Ductile. You can draw it into a wire.
Yes.
Malleable. You can pound it into a sheet.
Done. Pound it flat.
Mhm.
Luster, scientific word for shiny.
Shiny.
Conduct means to allow to pass through. So we let electricity pass through.
Yep.
Okay, good. Chemical properties of said alkali metals.
They want to lose their one electron, their one valence electron, so they become +1 ions. They're extremely reactive. They would never be found in nature by themselves. And they react violently with water, as you can see.
That is sodium metal, and here comes a pound of sodium metal. Dude just launched a pound of it.
Skipping stone. Boom! A little chunk falls, and then it's a different kind of skipping stone.
Yeah, it's skipping all by itself. Look at this.
Boom.
That's mad
Boom.
wavy. Mad wavy.
Dangerous, not to mention.
That's why I put a video of it up, and now we're not doing
Not
that.
to mention the sodium hydroxide
Oy.
they made in the pond for all those fishies.
All right, quick
But
notes.
notes, they contain the most reactive metal, francium. That's at the very bottom of the alkali metals, and reacts so fast that we really have trouble proving that it has metallic properties,
'Cause it can't be
or
around
keeping it as a pure sample for any meaningful amount of time.
It
So
reacts so fast.
let's go on to these alkali
Alkaline
earth
earths.
metals.
Physical properties, guess what? All the same as the last one, except for now 2 valence electrons. Do you need to write all these to get your notes?
Uh-huh.
Yeah. Do you think these things are important for metallic properties?
Uh-huh.
See what I'm saying? You write them, I move on. Chemical properties. They easily lose their 2 electrons, becoming +2 ions. They are very reactive and rarely found alone in nature. And this is magnesium in row 2, reacting like a crazy.
And here's the deal. In my lab, in my class, if you've watched this video and see that this is magnesium ribbon lit on fire and want to do it yourself, you come and ask me. We'll do it one-on-one in the lab.
Yeah, I already did it for some classes, to be honest with you.
I'm doing it to see if they pay attention.
Oh, nice. Remember, 2 words, 2 group 2. Key,
Mhm.
okay?
Absolutely.
Move next.
We've got transition metals, all those middle guys. The valence electrons vary. They don't follow the same pattern as the rest, but they are still metals, so those 4 things are still going to apply here.
Oh, yeah.
They form colored ions in solution. Copper makes a bright blue in water. They are unpredictable. You don't know if they're going to lose or gain their electrons. Depends on what else is there with them.
Yeah.
And they are the least reactive of the metals.
Absolutely. These are the metals that you could find bare naked on the surface of the earth, like gold.
Right. And they're found in the middle of the periodic table. So we say the middle metals need a middle name. So when we get into naming these and bonding, the middle, right, we will introduce Roman numerals to help us understand, is it iron 2 or is it iron 3? We need to know.
Yeah.
Because they have multiple oxidation states.
Absolutely, positively.
Okay, halogen, monocolor.
Halogen, physical properties. So these are the first non-metals. They have 7 valence electrons. They make up the non-metals. There's 3 states of matter found represented in this group. Solids towards the bottom, liquids smack dab in the middle with bromine, and then the gases are at the top.
Yes, I've seen that as a multiple choice question.
Chemical properties. They like to gain 1 electron to become -1 ions, and they form salts or compounds that are called halides. And this is a picture of some chlorine gas reacting with some sodium metal to make, well, nasty.
Fun.
Probably salt, sodium chloride, but a lot of other stuff in there too.
Yeah.
This group contains the most reactive nonmetal, which is fluorine at the very top. So fluorine and francium. Fluorine's the most reactive nonmetal.
That's way
Top right corner of the periodic table, except for the noble gases, and francium, bottom left. So they're at opposite corners of the boxing ring, if you will, and they're the most reactive of their own species.
Ding ding. He said boxing ring.
Yep.
7 diatomic elements. There are 7 of them. Notice they are in purple in the picture. These are the special elements that exist as 2 atoms of 1 element bonded together. You will never find a single atom of oxygen by itself in nature. It will be bonded at least to itself. There's 2 ways to remember. First is the acronym Hofbrinkel, which is literally all of the elements, H, O, F, B, R, I, N, and Cl. And the other way is the 7H club. And so let me just show you real quick. If you start at element number 7, which is nitrogen, you can make a 7 and then an H. So that is how we get what we call the 7H club.
Crafty. Crafty.
Okay.
See noble gases, you know?
Sure, those are the ones all the way at the end. They have all of their 8 valence electrons filled up, so they're not really going to react with
Nothing or
other
nobody.
things. Yep, they are all gases.
Hence noble gases.
Yep.
Oh, here we go again. Yeah, they are still unreactive, and they're going to be alone in nature. They are stable.
Yes.
And that is a picture of a neon sign, which we've all seen.
Interestingly, these were the last elements to be discovered because they were unreactive.
Yes.
Helium is the only one that is accepted to the octet rule because it has a very simple electron configuration. Its innermost electron shell can only carry 2 electrons, so it's considered full with just 2 instead of 8. So,
You'll
but
hear us say octets or duet.
very important for bonding is that every element wants to have a noble gas electron configuration, meaning it's got 8 electrons for 2 in its outside ring. So all the elements in the periodic table will react in order to fulfill that rule. Fill up or empty out your valence shell so you can be stable like a noble gas.
Right.
8 is great.
Right. And one of the overarching themes of the year is the universe likes lower energy, stable. Okay, lanthanide, we're going to go through this one pretty quick, right? Valence electrons vary, does have all the same metal properties.
Yep, because it's a metal. Even though it's detached and below, it is part of the transition metals family.
Yes, it is. And I think I probably left out luster.
Yeah.
Yeah, but that's okay. Chemical properties. When exposed to air, they react with oxygen to form oxide coating that tarnishes their surface sometimes. And there are 2 rows on the bottom detached. They actually belong to the transition metal family. You see in this picture, the space is missing. And in yours, there's an actual
Blowout.
blowout.
There's a thick
showing
black
it goes
line
there.
here and a blowout. So you should actually cut the periodic table here, open it up, stick these 2 here,
But then
and that would be a really long periodic table.
that would be very
Never fit on a piece of paper. So.
Acidanide is also
You say it wrong all the time. Actinide.
actinide. Yeah,
It's okay. I still love them.
I say francium too. He says francium. Tomato.
Yep.
Here's the big boogeyman.
Radioactive.
Yeah.
I eat them for breakfast.
Yeah. Plutonium's there and uranium are there.
Yep.
So paramagnetic and very weird different crystalline phases. I'm kind of going through this one fast because guess what?
They don't matter that much.
Yeah, we're not here very often. We stay in the other groups a lot more. So again, actually belong to the transition metal, so these notes.
All right, let's pick up the pace because we got to get something that actually matters.
Oh, hydrogen.
Hydrogen. It's not toxic, not metallic, odorless, tasteless, and it is a colorless diatomic gas. That is technically in a group of its own, which is why we spent a whole slide on it by itself.
Yes.
Very combustible. Kaboom.
Which means boom.
It's
Burn.
part of rocket fuel. Although it's classified as a non-metal, it can act like a metal sometimes, which is why it's living with the alkali metals. It's technically detached
It is.
from the group. So
Gases
while it
float.
sits up here, it's not actually part of this group, which is why we gave it its own slide.
No. But it
Hydrogen?
can form a positive ion, which means it could potentially act like a metal.
Facts.
States of matter.
Three states of matter.
Ready? Liquids first.
There's only 2.
Mercury and bromine. We got a liquid metal. We got a liquid non-metal.
Yep.
We got a few gases, and then that's it.
Yep. And then everything else is a solid.
Right.
Hydrogen, helium, nitrogen. Again, like the Hofbrinkels and
Gases.
the noble gases. That's really it.
That's really what it is. It is the Hofbrinkels and the noble gases.
Maybe
That's
next
good.
year we'll put Hofbrinkel in order and the noble gases right next to each other.
Yeah, maybe we'll do that.
Name diatomic 7 and the
You know
noble
what's
gases.
best about the last part? Everything else.
It's a solid. Exactly.
Go ahead, say it.
Everything else.
Everything.
And they're smart.
All of it.
Oh, could we?
Could we possibly be done in time?
Oh my God, it was such a long video.
Let's find out. Click it.
We made it!
Oh my gosh.
You might have to watch this one again because there's some important stuff in there. So,
No.
happy trails and press the button.
You know, it'd be really embarrassing if they got to see me trying to figure out where this button was every time.
So embarrassing.
Because I sing that little song and it would just